Use the compound interest formula to compute the total accumulated amount in the interest earned. The formula we're looking for here is A equals P 1 plus R over N to the N times T. So on the side, I'm going to write down all the givens. The principal is $1,000. N is 1 because it's yearly compounding. T is 10 years. And R in decimal form is 0.01. Now we want to just substitute in. And then enter this on calculator. If you've entered it correctly, you should get A equals 1104.62. Now in order to go to the next step, to find the interest earned, we have to use that old formula of A equals P plus I. The accumulated amount in the account is the principal plus the interest. Now we know the accumulated amount is 1104.62 after 10 years. And we know the principal that was originally invested was $1,000. If we rearrange the equation, we get I equals A minus P. So plug in. The interest is $104.62. So what would this have looked like as a graph? Start off with 1,000. It grows after 10 years to a new amount, 1104.62. And the picture demonstrates how the account is a sum of the principal and the interest. So the principal is 1,000, and the interest is 104.62. When you add them up, you get the accumulated amount in the account. The next question says, what if $1,000 is invested for 10 years at 1% interest compounded continuously? Now, when it comes to continuous compounding, we actually have a different approach. We want to use the formula A equals P E to the RT, where P is the principal, E is an irrational number that's a transcendental number in mathematics, approximately equal to 2.71. You can actually bring up a calculator and find out what E is by hitting the E button. That's the number E, 2.71828, and it keeps going forever without the digits repeating, which makes it an irrational number. R is our interest rate, and T is the time of compounding. So let's plug in $1,000 of principal. E is a button on your calculator. raise that to the 0.01 times 10. Now, how will it actually be entered on the TI-30 X2S calculator? You should type in 1,000, then hit your E button. It's going to bring up a caret because you want to put an exponent in there. And do 0.01 times 10 inside the parentheses, though. Gives us 110517. Okay. So the interest now will simply be I equals A minus P. And that's going to be 105.17. The next thing I'm going to find is a formula called the present value formula. The way it's found is by solving the compound interest formula for P. If we start with A on the left and P on the right, then all we need to do to get P alone is divide both sides by this big factor 1 plus R over N to the NT. That would cause it to go away on the right side, and P would be alone. So what's our answer? P equals A over 1 plus R over N to the N times T. It's called the present value formula because it would allow you to decide how much you have to invest today in order for your account to grow to a certain desired value. Let's see how it works. The desired accumulated amount in an account is $100,000 after 20 years. You want to invest it with a 4% interest rate that's compounded annually. And we want to use the present value formula for discretely compounded interest to determine the amount to be invested today, or the present value that's needed. So let's write down the givens. What is A, the desired accumulated amount? $100,000. And the idea being here that we want to start with a certain principal P and have it grow to $100,000 over time. We want it to take 20 years. So our goal is to figure out what is P. That's when you use the present value formula. We also see that N is 1 because it's yearly compounding. T is 20. And R is 0.04. All right, let's write our formula. P equals 100,000 divided by 1 plus 0.04 over 1 to the 1 times 20. Okay, now how will you enter this on calculator? I'll do it on the side here. You want to type into your calculator 100,000 divide by parentheses 1 plus 0.04 over 1, close the parentheses, raise it, that's a times, raise it to the power of 1 times 20. That's how it should appear on the TI-30X2S. And in finance math questions, you typically want to round to the nearest cent. Okay. Now let's take the formula for continuously compounded interest and rearrange it for the variable p. Start with the formula A equals PE to the RT. In order to get P alone, we'll divide by E to the RT. That causes these to cancel. And then we get our present value formula, which is A over E to the RT. Let's say the desired accumulated amount is $100,000 after 20 years invested in an account that earns 4% interest compounded continuously. Use the present value formula for continuously compounded interest to find the amount that should be invested today to achieve $100,000 in 20 years. So for this, A is 100,000. They're asking us for P, so we want to use this version of the formula. R is again 0.04 and T is 20. So let's plug in. Okay, I get 44,932.90. Notice that here you don't have to invest quite as much today as you would have in this account because of the frequency of compounding. Now in this example, the differences between the accounts is quite modest, but in many real-world situations, when the interest rate may be higher, there could be quite a difference between the accounts, especially if it's extended over a long period of time.